everybody. We're going to get started today. Welcome to today's virtual Mind Walk. Thank you all for attending. My name is Carissa Town, and I am a park interpretive specialist with California State Parks. And today we've got a great presentation ready for you. Thank you, Steve, for being here with us today. Before we begin, I just want to go over a few things. Virtual Mind Walks are a lecture series hosted by California State Parks and the Central Coast State Parks Association. They are hosted twice a month on Fridays and are free for all to attend. You may check out the list of upcoming lectures and an archive of past recordings at CSPA's website, which is shown right here behind me on the screen. The Mind Walks program is underwritten by the Thomas E. and Mary Kathryn Eltzroth Fund and are supported by the Central Coast State Parks Association. Today's presentation will be roughly 30 to 40 minutes with time at the end for questions. To ask our presenter a question, please, you can use the Q&A box. At the bottom of your Zoom window, there's a little icon that says Q&A. Click on this and there will be a field where you can type your questions. You may ask your questions anytime during the presentation, but we won't be able to get to them until the presentation is over. Today's program will be recorded, so if you need to head out early or want to share this presentation with anyone else, it's available to watch next week. Sign up for CSPA's newsletter to receive a link to watch that once it's uploaded. All right, that's all for housekeeping. Now let's introduce our speaker. So Steve Schubert attended Cal Poly San Luis Obispo, receiving a master's degree in field biology and life sciences secondary teaching credential. He taught high school biology and earth sciences for several years and has taught history courses for Cuesta Community College programs for over 25 years. And he has worked as a naturalist instructor at the local residential outdoor school program called Camp Keep. He served on the committee that published the book Wildflowers of San Luis Obispo and the ebook Plants of the Carrizo Plains. Steve authored the book Peregrine Falcons of Morro Rock, a 50-year history, and he is the past president of the Morro Coast Audubon Society and its volunteer coordinator of the High Mountain Lookout Program, a stored fire lookout in the Los Padres National Forest, where volunteers and college interns radio track the movement of California condors and conduct field biological research projects. He has been a speaker and field trip leader for the Morro Bay Winter Bird Festival for over 20 years. So I'll let you take it away, Steve.
Well, thank you. That long introduction just makes me feel like I'm getting old. There's a lot of years gone by there, but I want to thank you all for joining in today. And I'm looking at the participant list and recognize some names and friends among you. So first, it's just good to see some old familiar names and hopefully some faces if we can talk a little and chat at the end of my talk. I do want to clarify that I'm speaking to all of you from long distance today. At the beginning of the pandemic, I decided to leave my Central Coast residence and take shelter at home at my vacation and seasonal home and property up in the Pacific Northwest. So I am actually speaking to all of you today from north of Spokane, Washington in the mountains, over 1,000 miles long distance. And it's good to check back in with some locals once in a while. So I've been here a year and a half and look forward to returning to the Central Coast post-pandemic. I do need to mention I have fairly slow internet speed here in my rural mountainous area, so you may find my audio is not perfectly synced with my video, and sometimes my video gets a little glitchy, but once I begin the slideshow, I think that will work just fine. And with that, I'm going to start a screen share here. I have to tell all of you that when this all started a year and a half ago, I had never even heard of Zoom meetings. And here I am trying to give a Zoom talk today. I have been a guest speaker over the years at several of these Mind Walk in-person sessions. The last time I spoke was I think about 3 years ago on the nesting peregrine falcons of Moore Rock, but I'm switching subjects today and wanted to present a talk, present about once a year through the Cuesta College community program classes I teach. So if this was an in-person meeting, we'd have this same lecture in the classroom, and then not all of you, but about a dozen of us would fit into a van and we'd go on a van field trip. So today my goal is to take you, when we reach the end of this session, on a virtual field trip through some of the Central Coast paleontological sites. So with that, paleontology, ology of any science means the study of, so paleo meaning ancient life, the study of ancient life, most frequently preserved in the rock record. And of all the carcasses found on the Earth's surface after recent death, the vast majority will never be recorded in the fossil record. So it often takes some specific environmental conditions for preservation. Often a carcass that lies around on the Earth's surface will be decomposed. Bacteria and fungi, for example, will be scattered, the bones scattered by scavengers, and just simply will never show a future record in the fossil record. But under the right conditions, often involving rapid burial, for example, on a deep seafloor or quiet deep lake bottom, covered by sediments or possibly volcanic ash flows, rapidly covered, buried. Sometimes these conditions, especially if there's low oxygen availability, will reduce or prevent decay activity. With time, millennia and millions of years go by, and that specimen may be preserved in the rock record someday to perhaps be discovered when uplift and erosion can expose these fossil finds. So briefly, again, generally deeper, often water conditions like the bottom of a lake, or shallow or deep marine seafloor conditions where there's, again, burial, protection from decay, and eventually deep burial and compaction will help promote the likelihood of something possibly becoming fossilized. So I'm going way back to my first paleontology course that I took at Cal Poly, and even though my grad degree is in biosci, I found I had a real love for the earth sciences as well, and in particular, I took all the geology. Generally, we say there are different modes of preservation, including unaltered. For example, the body, the carcass is completely preserved almost in its intact natural form. Many of you are familiar with the term amber. If you think back to the movie Jurassic Park, this is petrified or fossilized tree sap. And if organisms such as insects become entrapped in that, millions of years later, we can still study them in near perfect condition. Then there's another form of unaltered preservation, usually exposed to extreme cold temperatures, such as in glacial environments. So intact mammoth carcasses, for example, have been found with even skin and hair and organs still well preserved, which allows us to even do molecular DNA studies, and that's remarkable. The other form of or mode of fossilization is generally referred to as altered. In some way, the dead organism was altered over time. So as we go through the talk, I'll be talking about permineralization. Maybe I shouldn't say it or talk about it if I can't pronounce it. We'll be talking about molds and casts, replacement, compression. These are some of the terms that describe fossilization when something has become altered over time. And a great example that we're all familiar with is petrified, which means literally turned to stone. So some petrified wood, the actual organic material may not even exist at much level, where it was replaced instead by waterborne minerals underground that filled in spaces, for example, and hardened into solid stone. So for example, this petrified wood might actually be made of quartz, for example, which might have been the mineral formation that helped form this. So back to the idea of unaltered. It's again an example we've already mentioned. For example, cold exposure or mummification. Another example is that the actual shell material, for example, could be seashells, it could be teeth, perhaps are truly unaltered and preserved over great expanses of time. And then we mentioned the amber example of fossilized tree sap. I was in on a virtual lecture just earlier this week, and I was listening to the presenter, and I was shocked when she said that even a baby bird has been found fossilized within this tree sap amber. So that's another remarkable example of unaltered preservation. Carbonization is simply a thin film of carbon. Think of charcoal, for example, where the organic remains are compressed and reduced to a very thin, fine layer of charcoal or carbon, not uncommon in leaf fossils, as well as some animal imprints. So another example of petrification, or similar to being petrified, is the term replacement. So an example would be perhaps a clam shell buried deep in the sediments. The sediments harden into rock. Eventually, water moving through the pore spaces might completely dissolve the original material, and it's completely replaced with other mineral solids. So another example of altered fossilization examples. Another type of mode of fossilization is sometimes referred to as trace fossils. Examples, animal trails like dinosaur footprints, animal burrows burrowing through the sediment, and those spaces may have eventually filled in with sediment and hardened, but leaves behind their evidence of their burrowing activity. Coprolites, interesting, that's animal excrement that can be fossilized. And it actually helps us reconstruct ancient food chains and food webs and what was their dietary behaviors. And here's a quick example of the geologic time scale. Like layers of rocks were generally the upper layers are the younger layers that were overlain and deposited on top of the older layers. Think of the geologic time scale in a similar fashion. Generally, at the bottom of the scale, lower in the scale, is an older time period. So as we move up through the geologic time scale, the passage of time is much more recent. And we can break down geologic time into what are referred to as eras. So here's an example. Beginning some 500 plus million years ago, the Paleozoic era, which lasted a great length of time until well over 200 million years ago. That's an example of, for example, some of the early life forms appearing in great abundance in the fossil record. We also break down eras into smaller units, for example, called periods, and periods are broken down into smaller units known as epochs or epochs. Someone needs to help me with my pronunciation. An example of an invertebrate found throughout the Paleozoic, many of you are familiar with the term trilobites. I took this photo at my local county fair just last summer because this was a local find where I am here in Washington State. These critters related to arthropods, examples being insects and crustaceans, had a wide ranging period of existence and then became extinct at the end of the Paleozoic. So many of these geologic eras and periods come to an ending with some catastrophic extinction event. So these animals have been extinct on this planet for well over 200 million years. So I was just talking with a neighbor this early week again. She knows the area much better than I do, having lived here longer. And she told me that there's a ridge not far from where I'm looking out my window right now, where Smithsonian scientists years ago came to an outcrop to find trilobite fossils. So she got my attention, and now we're going to try and get permission with the landowner and see if she could take me back there and show me where this outcrop is, right here in my own neighborhood. So fossils reveal much more about the past Earth's history than just the history of life. One theory, the theory of plate tectonics or continental drift, is in part supported by fossil evidence. Here's the ancient supercontinent Pangaea that existed before the age of the dinosaurs even began, during late Paleozoic, where we could reconstruct most of the world's land masses were all connected to this giant supercontinent Pangaea. Well, the fossil record helps support this theory. So if you all notice how, for example, the bulge of South America fits nicely into the what am I going to call this? The concavity here of Africa. It's like a jigsaw puzzle, suggesting at one time perhaps connected long ago. Well, the fossil evidence helps support that. Here are some fossil finds, for example, only found in the southern landmasses of our world. And these species of ancient fossils suggest, because they're so widespread on the different continents, where today there's intervening thousands of miles of open ocean, that perhaps at one time the land masses were connected. Another example of a reptile called a mosasaur, found only in limited areas of South America and Africa as fossil finds. And unless these were adept long distance swimmers, and their anatomy doesn't indicate that they necessarily were, this suggests that maybe the land masses were connected. Good evidence for continental drift. And then, of course, fossils provide a direct form of evidence for the theory of evolution and how life changes through time. So much of our understanding of that today is by molecular DNA studies, but the fossils themselves help provide direct evidence of evolutionary history. Again, this is the talk I joined in on earlier this week, and the theme of the talk was about avian dinosaurs. And you might be familiar with the recent fossil finds over the last 20 some years in China, for example, of spectacular finds that show the bird dinosaur connection. And in fact, there is more and more consensus about among biologists that birds, in fact, might be living feathered dinosaurs, and that there were dinosaurs that could fly. And dinosaurs, many dinosaurs had feathers, including Tyrannosaurus rex and Velociraptor. So this transition and evolutionary history is quite remarkable, showing the bird dinosaur connection. Well, that's a whole talk all to itself. So now I'm going to start taking you on a virtual field trip. It's not exhaustive. I can't take you to all the well-known sites, but these are all sites I personally have visited over my travels over the years, and wanted you to encourage you to either take a virtual visit, maybe look some of these sites up and do some more online learning, or make an in-person visit. So here's stop number one. We're going to focus on the Western United States. In central Nevada, among high desert juniper woodlands, dry, arid, hot, is Ichthyosaur State Park, where once giant marine reptiles, similar in this appearance to a shark in some ways, or you might even think something whale-like, but these were marine reptiles that roamed ancient seas. Some were small and some were huge, like whales. Marine predators, and you could visit the state park and still see embedded bones in the bedrock that haven't been completely excavated. By reconstructing their location, the thought here is that perhaps they washed up on a shoreline dead, or in that shallow marine environment on the edge of ancient supercontinent Pangaea, when North America was connected to the vast land masses of that time. This dates back to the early Triassic period of the Mesozoic era. This is near the beginning of the age of dinosaurs. So you can go into the visitor center, which built over the rock outcrops also helps to protect these exposed fossils from the elements of rain and wind and erosion, and see these fossils still embedded. And it's fun to just take a walk around, take a look. Here are some plate-like vertebrae or backbones. Now, I used to teach high school in the Sierra Nevada foothills in a town called Mariposa, which is a gateway city to Yosemite National Park. And I was living in the Mother Lode where the gold rush happened. In fact, my actual home and property was on one of the historic gold mining districts. And not far from me was the Mariposa slate quarry. And I knew a little bit about it because apparently this rock slate material was used even in San Francisco mansions for flooring material, for example. So had a history, of course, selling rock for building material, but I happened to visit one day. This photo is very old. And I started looking closely at these slabs of rock, which likely represent deep marine deposits millions of years ago, and saw ancient ripple marks in the slate, suggesting the disturbance of the bottom layers by currents. And then I took another look and found these wiggles in the rock. So this is me speculating, but could these be examples of animal activity? An example being worm tubes as worms burrow through the sediment. If this is a correct interpretation, we would call these trace fossils, traces of past activity. So our next stop is in Arizona in the Painted Desert. And this is the famous Petrified National Forest. And it's in an area known as Badlands, like the South Dakota Badlands. The sediments erode away fairly easily and leave this rugged landscape. And when the soils and rocks erode away and expose what's buried, you'll find these massive fossilized tree trunks spread all across the landscape. And there are hiking trails that take you out into the Badlands. Well, if you take a visit, this is one of my favorite parts of the visit. When you go to the museum, they have an entire glass display case of conscious wood. When you're on public lands, including a national park, a national monument, all natural features are protected. So you're not supposed to pick up and take home souvenirs. And of course, over the years, people did. Parents with their children, taking a little piece of morsel of a fossil home and putting it in their pocket, taking it home, and then feeling really guilty about it and trying to send it back and say, will you please put it back? They'll send letters with the fossil included. Everything's gone wrong in my life since I stole this fossil and brought it home. You know, the pipes have ruptured in my house. I got divorced. And so they try to redeem themselves and send back their pieces of conscious wood. And so they had an entire collection of that. This is a giant crocodilian-like reptile found in the desert of Arizona. So again, fossil remains also help reconstruct past climate conditions. In fact, it may have been much more tropical, wet, humid, and lush green vegetation in what is now dry desert. Here's a paleontologist at work. Often out in the field, they'll put a plaster of Paris jacket over fossil remains to help protect them from fracturing and breaking when they actually remove them, bring them back to the lab for study. Next stop is Dinosaur National Monument. And this happens to be in I believe the Uinta Mountains of northern Idaho. It's also where the Green and the Yampa rivers confluence joins. So spectacular scenery and geology, and there are campsites here. It overlies the boundary of both Utah and Colorado, and you want to specifically make a visit to the quarry site, where the rock formation, the famous Jurassic Morrison Formation, is where so many dinosaur fossils have been found and excavated. They built the visitor center right on the quarry site. Here's the uplifted or almost vertical rock surface. This has to do likely with the uplifting of the ancient Rocky Mountains long ago. And you can visit indoors and see these bones still in situ. And many of them will never be excavated completely. They'll be there on exhibit for the public visitors. and you'll have like park rangers speaking to you about the actual bones you're witnessing. Some paleontologists are still at work. While we're all there gawking, this paleontologist was working with tools to slowly, gently expose fossil specimens. This still was hot desert conditions. Look how she's using a fan here to help cool herself off while she was at work. And as visitors, you can be on site and get the spiel from the rangers as you observe. So for example, I think if I recall, this is one femur, long as a human being, of a four-legged brontosaurus-like dinosaur. And you can reconstruct from these individual bones what the critter was. And this area, Dinosaur National Park, is renowned for, again, the Jurassic period, kind of the middle era of the Mesozoic era. At the time when I took this photo, and they had it behind some film, plastic film here, this was a replica, one of the most intact dinosaur skeletons ever discovered right there at that location. Next stop is another location in Utah, Escalante Petrified Forest. And once again, go out for a walk on the trails and you'll find these beautiful mineral stained petrified wood stumps among the living trees. But these stumps date back to the age of dinosaurs. Speaking of dinosaurs, one of my favorite travels was to the prairies of southeastern Colorado, to the Comanche National Grasslands, because it's famous for dinosaur trackways along the Purgatory River. And I remember this day, even though it's accessible to the public, I had to park my car and hike in several miles. So I happened to go jogging instead to reach this site. And these are famous dinosaur trackways along the edge of the Purgatory River, suggesting so much about possible behavior and social structure. Were these animals walking in herds, just like herds of cattle or elephants? Were there young animals being attended by the adults? So much behavior can be possibly deducted by these tracks. Were there predators like the three-toed theropods that might have been hunting some of the? Here's a scale for me sitting or kneeling next to a puddle of water, but that's one single dinosaur footprint. And there's my footprint or foot to compare in size to the dinosaur track. So again, back to the Mesozoic era, the age of dinosaurs. Now, at issue is these tracks are exposed because of erosion, likely along the course of the Purgatory River. And notice how the blocks of rocks are still breaking off and crumbling. Think of high water levels, for example, during a flood event. With time, these tracks will disappear from the geologic record through exposure and erosion. Carboniferous, just bringing up the point when we often hear of the phrase fossil fuels, perhaps folks don't connect that to what that really means. And in particular, during the Carboniferous period near the upper or late Paleozoic, were these vast swamps of tall trees, early primitive trees, and eventually their organic remains became preserved in vast coal formations. So when we talk about mining coal or oil drilling and natural gas, the term fossil fuel really relates to the fact that that is the remains of organic, once living organisms that became fossilized and became a future energy source in our modern society. So one time I was traveling in Wyoming to get to a site, and there just happened to be this display of dinosaur tracks in coal deposits. And it turned out some miners were, I believe, dynamiting underground in a coal mine, and this broken piece of coal was what they discovered with dinosaur tracks roaming through those ancient swampy forests. So Southwestern Wyoming, Well, no, we'll get to that. Northwestern Wyoming, Yellowstone National Park, renowned for its thermal activity and geysers, but also renowned because of the Yellowstone River eroding through these ancient volcanic slopes, exposing fossilized forests. And here is a petrified tree stump still standing in its vertical orientation, exposed by erosion, probably originally formed during perhaps a volcanic eruption event. Perhaps this had at one time been completely buried by volcanic ash, petrified, fossilized, and millions of years later exposed to the surface. And I think of this as a ghost forest. The petrified forest of Yellowstone National Park. Okay, southwestern Wyoming is famous Fossil Butte National Monument. It's near a town known as Kemmerer, which I think I recall is the first city to ever open a J.C. Penney's. If you want some more recent history, not quite so ancient. And this area is renowned all over the world for its spectacular fish fossils in these ancient lake sediment deposits. We're going back to about the Eocene epoch, some 50 million years ago, and there are spectacular fish fossil deposits in this area. Freshwater stingrays, spectacular. There's the barb on the tail. Garfish, which still survive today in, I believe, the deep south rivers. And this is a living fossil that has a long evolutionary history. I think I recall this exact same specimen as a photograph in a textbook, because this one died and was fossilized in the act of swallowing its prey. So here's the tail end of its prey being swallowed, and predator and prey became preserved in the fossil record. Amazing. One of the oldest bat skeletons ever found, fossilized, dates back to around 50 million years ago, found in the Fossil Butte Formation of this area in Wyoming. So again, this likely was not only lake bed, it was a completely different climate, perhaps more tropical vegetation, wet and humid at the time. The boa constrictor fossil. Those are now largely restricted to Central South America. So this again shows range changes over the spans of millions of years. So now we're going to move on to another location in Oregon State, the famous John Day fossil beds, east of the high Cascades, the Cascade Volcanic Mountain Range. We're now in the Cenozoic era, which is also known as the age of mammals. This is post-dinosaur, after the great dinosaur extinction, some 65, 66 million years ago. Then the spectacular evolutionary radiation of mammals and birds too. So you can visit these spectacular rock formations again on public lands. Many of the area has marked, well-developed trails. And here was a saber-toothed cat eroding out of soft volcanic rock formation, still in sight. There's the skull, and these are some of the vertebrae. A tortoise, an extinct tortoise. This would be the lower part of its shell, known as the plastron. There are different units in the John Bay fossil beds. This is the Clarno unit, and it's known for its plant fossils. For example, here's a fossilized log in the volcanic formation. One of the thoughts or theories about this is that perhaps this was very similar to modern times, where a volcanic eruption, especially covered with snow and ice, and the water melting and the heat can cause immense debris flows flowing down the mountain slopes of these ancient volcanoes. So perhaps this log was being tumbled around in an ancient, what might be called a pyroclastic flow, before deposited miles and miles away from its source. The Clarno area is also known for fantastic leaf fossils. One kind of leaf fossil are known as rolled leaves. So again, why is this leaf all nicely rolled around a pebble? Could this have been related again to one of these violent, turbulent flow events during a volcanic eruption. But this particular area is known for this style of leaf preservation. Another unit of the John Day beds is the painted hills. Unfortunately, my photos won't do justice to the colors, but it's worth a visit, especially near twilight hours, just to see the spectacular colors in the rock formations, the painted hills. Also is the leaf hill, nicely fenced off here, where you can get close to some of the renowned leaf fossils. Well, you're not allowed to go collecting and digging again on these nationally protected public lands, but if you find your way to the tiny community of Fossil, Oregon, there actually is a location right on the school's baseball field behind the dugout of the baseball field where you are allowed to go dig in the rock outcrops and take home some fossil souvenirs, very similar to what I was discussing in the John Day fossil bed. So I did the same thing, got the crowbar out of the trunk of the car and went up there and chipped some rocks and brought home some souvenirs. Another location renowned for leaf and plant fossils in general is in the northeast corner of Washington State, actually not so far from me, about an hour drive where I'm speaking to you from. And the Stonehill Fossil Site, also known for its spectacular plant fossils. And you, besides making a visit to their nice visitor center, you can have access to a quarry site and bring your rocks back to the laboratory, to the museum and visitor center, and their staff will assist you with identifying your fossil finds. So this is the rock I quarried out of the quarry site that's open to the public, brought it back to the lab, split it open, and this is what was revealed inside this triangular shaped rock here. So I have this fossil sitting right here. I'm looking at it right now, and their staff even labeled all of the different fossil finds for the visitors. I hope I have this correct, but I believe this leaf impression here is metasequoia, also known as the dawn redwood. And if that's correct, I'll have to go back and look at my own rock here in a few minutes after this session's over. The metasequoia is related to the giant redwood tree and the coast redwood, and during the age of dinosaurs was widespread over much of the world's landmass, became extinct in North America, and was not even known to exist, but now known to occur in locations in China, or a species of this metasequoia is still known to exist. And this is actually a widely planted ornamental tree now across much of the world, but at one time thought extinct, so it can be referred to as a living fossil. Along the Columbia River in central Washington, again in the high sagebrush desert along the river, are rock outcrops known for a very famous tree fossil, and it's ginkgo petrified forest. Ginkgos, again, are a living species, once much more widespread in the fossil record, again thought potentially extinct, and is now found in China. I once read, and I don't know how accurate it is, that it may have been planted by Chinese monks for hundreds of years and protected and grown, and then rediscovered as not being extinct after all. There may also be truly wild populations in China, but at one time this species was thought extinct. This heritage of this plant goes back again to the age of dinosaurs, where many species of ginkgos once existed. Perhaps dinosaurs munched on these. So you can make a visit. They have some petrified ginkgo trunks on display, nice visitor center and museum with specimens on exhibit. And then you go out and take a walk on the pathways and you'll still see fossils, in this case, protected by hardware to protect, hopefully, from stealing and vandalism as well. But you can still see trees embedded in the rock formation that have not been removed and excavated. High desert today, but at one time, a much more wet and perhaps subtropical kind of climate. We're talking about tens of millions of years ago. All right, I want to start wrapping up the talk with some more recent periods of historical time, and that includes the Pleistocene Ice Age, which ended some 10,000 years ago, and Hancock, Park along Wilshire Boulevard in downtown Los Angeles is world renowned for the La Brea tar pits. And this asphalt material rising from the interior of the earth for thousands of years has entrapped animals who came down to the edge of what once might have been ancient lakes, for example, or maybe rivers, and not realizing the asphalt conditions below the surface where they might have come down to drink, for example, would cause their eventual entombment. And so many, millions of specimens have been recovered from this site. This is world renowned for Ice Age fossils. And the Page Museum is right on site. So some of these pits that have been dug and excavated for many decades have revealed extraordinary Ice Age fossil finds. So the asphalt or the tar is still emerging even today at the Earth's surface. When you make a visit to Hancock Park, here's some specimens still not fully removed from the tar. This is looking at the underside of an elephant skull. Perhaps this is a mammoth. You can see the tooth rows here of an elephant. Here's the opening to the spinal cord. This is probably one of the limb bones here with the ball joint. So spectacular Ice Age mammal finds. Take a visit inside the museum. I know many of you have, by the way, that are listening to this talk. I've made several trips there. It's always new and refreshing every time. So imagine what is today semi-arid Los Angeles basin, once at the time of the Ice Age, wet, cool, rainy, lush green vegetation, thriving herds of animals, predator and prey. The saber-tooth, by the way, is the official state fossil of California. And I was doing some reading background to prepare for this talk, and I believe about 2,000 skulls of this saber-tooth have been excavated from this site alone, but only 3 mountain lion skulls have ever been found in the same tar deposits. So it's fascinating to wonder why. Did it have to do with different population levels? Did saber-tooths displace the mountain lions of that time? But they have found modern mountain lion skulls as well. This is the imperial mammoth, proving that elephants once roamed California. And we're not talking millions of years. Now we're talking tens of thousands of years ago. Giant ground sloths, a relative of anteaters, perhaps standing on its legs, munching on vegetation. This critter might have had a weight of about a ton at the time. Again, these are now extinct species. Many of these mega-fauna became extinct near the end of the Ice Age. Horses, the giant bear. Horses evolved in North America, according to the fossil record, eventually became extinct, having spread to other continents. But here in North America, reintroduced several hundred years ago by Spanish conquistadors, but a species that actually evolved first in North America. And you might be familiar with wolves, but this is the dire wolves. Look at the tremendous number of specimens that have been exhumed from the tar pit deposits. Now, birds don't fossilize readily because of their thin, hollow, fragile bones, which are easily scattered and dismembered. But the tar pits, entombing these birds have revealed an amazing record of bird specimens, including ancient condors. The Teratornis, an ancestor or at least a relative of today's California condor, was much larger, perhaps a 12-foot wingspan. Now, I'm speculating that some artists drew the interpretation of the plumage of this extinct condor by using the existing California condor, perhaps as a model for how it might have appeared. But it is amazing that paleontologists now can chemically analyze bird fossils, and trace elements have actually allowed paleontologists to deduce what the actual colors and plumage patterns of these extinct birds were like. So they can even reinterpret or interpret perhaps past feathered dinosaurs living during the Mesozoic era, not just trying to imagine from their bones and skeletons what they might have appeared like, but from chemical analysis can even suggest what their actual color and plumage patterns were like. To me, that's amazing. At the Page Museum, there's a roundabout paleontology lab where the visiting public can just encircle the paleontologists as well as volunteers at work, and you can see them doing what they do. After removing fossils from the tar, they need to be carefully cleaned, analyzed, cataloged, inventoried, and often school kids are on school field trips also as visitors to see scientists at work, not just on the big spectacular megafauna finds, but sometimes working also with microfossils. That includes, for example, tiny seeds and insect parts and pollen grains. Might be working with a microscope to even identify these finds, but this once again helps to reconstruct past geography, past vegetation, past climate conditions. And then it all gets put into inventory and storage. There are just so many, I suspect hundreds of thousands of fossil specimens in the collection, specifically at this one site alone. So here's an example of identifying, cataloging, and then placing into storage. Well, there are other tar pit deposits in California, by the way. La Brea is famous, but the tiny town of McKittrick in the southern San Joaquin Valley, across the Timber Mountain Range, for those who are local residents, the McKittrick area is known for some asphalt or tar pit deposits where there are Ice Age animal finds. And I should also mention, driving Highway 101 south of Santa Barbara, you pass through a tiny community known as Carpinteria near the salt marshes, and there are tar pit deposits in Carpinteria as well. And then the evidence that humans interacted with many of these Pleistocene megafaunas before their extinction. In fact, human hunters may have played a huge or participatory, I can't say it, might have helped play a role in the extinction of some of the megafauna. For example, mammoth finds that have projectiles found with them suggest human hunting might have played a role in their demise. So I want to finish up the talk with a local guided virtual field trip. This is where we would normally finish the talk, pile into the van, and go on a field trip. So we'll do it virtually quickly here and concentrate, since many of you are Central Coast residents, on the area of San Luis Obispo County in particular. So there have been some pretty amazing fossil finds locally in the Central Coast. Many of them are from the Pleistocene age. There have been some media coverages of these finds. For example, I'll get to that in a minute. This is one of my first field trips in the Central Coast area, with a symposium that was sponsored at Cal Poly, and there were guest speakers giving talks, and In fact, there was a slideshow on paleontological sites in Western North America. Well, that was my motivation for getting out and going on all those travels. And here I am giving a similar talk to you today. So this actually was the motivation for me that helped me develop this slideshow long way out in the future. But the Caliente Badlands are known for its fossil finds, including ancient or archaic mammal finds that could date back to the earlier Cenozoic era. So here we are out there in the Badlands where there's quite a bit of erosion exposing things on the surface. And for those who know, this is Ron Rupert, biology professor at Cuesta College, holding the ankle bones and wrist bones of an extinct camel. And he immediately, to my amazement, was able to identify what kind of critter he had found. These fragments were found right on the surface of the Caliente Badlands. Well, in the early 90s, some of you are familiar with the Point San Luis Lighthouse, now opened up for public tours. This was the opening of the Pecho Coast Trail from near the Diablo Canyon guard station at Avila Beach. And I was among the very first group of volunteer docents who started scouting this trail. And we began leading the first public hiking tours out to the lighthouse. Well, there was an extension option beyond the lighthouse for those of you who've been there, where you hike further north along the coast, along the coastal marine terrace to Rattlesnake Creek or Rattlesnake Canyon. And during one of those early surveys before the trail was actually open to the public, this spectacular mammoth tooth was found really close to the coast, having been exposed by recent heavy rains that year. This was 1992 era. And that tooth has not quite yet been removed from where it was found. So I was able to go out on a field trip, and I was really pleased just to see this and take photos of it before it was removed for study by Dr. Harry Firestein of Cal Poly, and eventually transferred to the Los Angeles County Museum of Natural History. So this was a spectacular find. I think of a Colombian mammoth, much larger than today's African elephants, roaming coastal California during the late Ice Age. This is its molar, by the way. This is the grinding surface on the upper surface of the tooth. So here's an old newspaper article from the, from the Telegram Tribune, dated 1892, and going through the paragraphs featuring a mastodon fossil find, which is another type of elephant found in the Central Coast area in the late 1800s. Made the news. Believe it or not, along the railroad tracks in Templeton, there are some marine deposits that are known for shell fossils. I don't encourage you to visit these sites if there's a traffic on those rails. And we're going to take an inland trip now from the coast. You actually mentally have to tilt this photo vertically, because this west to east is along Highway 58, and that's how I'm going to conclude the talk today. But this drawing, drawn by amazing geologist George Mason, and I'm using his line drawing here. He often gave geology talks, for example, at the Natural History Museum or the Inn at Morro Bay. Sadly passed away, but he came up with these spectacular drawings, and this dotted line, we're going to talk about in a moment, helps represent an ancient seashore inland of today's present coastline. And in fact, some of the mountain ranges we're all familiar with, like the Santa Lucias, at that time might have been islands rising from the seafloor. Well, when you travel along Highway 58 from Santa Margarita inland towards the Carrizo Plain, for example, you're taking a journey back in time. So as you cross over out of Santa Margarita towards the Carrizo, you'll come through, believe it or not, granite exposures. And some geologists think this actually is ancient Sierra Nevada granite that was displaced from the Sierras along the fault lines and the San Andreas Fault, and due to plate tectonic motion was later placed here in the Coast Ranges closest to home. For example, here's a quartz vein, just like the mother lode quartz that supported the gold rush of the 1800s. There was a mini gold rush in San Luis Obispo County in the late 1800s because there were gold deposits found in the La Panza range. Well, the reason I'm pointing this photo out, this is not the kind of environment you would expect to find fossils embedded in the rocks. Granite is an igneous rock from deep inside the Earth's surface that was formed by hot cooling magma. And that's not a likely environment deep beneath the Earth's surface where you're going to find fossil formation. So if you pass out of the granite, continuing east along Highway 58, you start to get into the sedimentary rock formations that were deposited over the granite. And this is the Vacaras Formation. And if any of you are ever attempted to repeat these kinds of outings yourself, I do want to caution you, I'm always on the lookout for cars driving way too fast along the highway here, and I have to give everyone a warning, get off the road, get off the road. So there is danger here with high-speed traffic. But we wanted to get out and study some of the rock outcrops. The Vicara Sandstone, which is the same rock formation, by the way, as famous painted rock on the Carrizo Plain with the Native American pictographs. This is ancient, shallow sandstone, perhaps near-shore beach deposit. It's not unlike today's modern Pismo beach. And the sand hardened into sandstone. There are even sand dollar fossils that have been found in this rock formation. Now we're continuing further east. And as I mentioned, the further east or inland we travel on this journey through time, the younger and younger the rock layers become that were overlain on top of the preceding layers. So now we're going to enter into the Monterey Formation, which geologically is considered younger than the Vacaras. And there are marine seashell fossils in the Monterey. The Monterey is regarded as deep water marine sediments that formed in a very deep ocean environment. An analogy today is today's modern Santa Barbara Channel between the coast and the Channel Islands. And in fact, the water may have been at that great depth, very low in oxygen. So one of the thoughts about this layer and layers of ancient mud, for example, turned to stone, is that there was very little disturbance to any activity or any carcasses that settled to the bottom. There was very low oxygen for decomposition by bacteria, for example, so it tended to create the conditions that help to form fossil preservation. So some of you familiar with the word chert, you often find this hard glassy rock chert in the Monterey Formation. Native Americans used chert to create projectiles like spear points and arrowheads. It is actually microcrystalline quartz, but the quartz or silica originated from ancient microscopic planktonic shells. So through metamorphosis, their remains turned into hardened glass, known as chert. When you split open the Monterey Formation rocks, if you're extremely lucky at this particular road cut we stopped at, there are fish scales. Notice how the fish scales match up along this area where the rock was split. Well, this particular trip, we stopped here for lunch, by the way, and one of my participants who was registered for the Cuesta College class came back with a rock in his hand. And he said, "Steve, look what I found." And he found this shark tooth embedded in the rock of the Monterey Formation. And I have that rock sitting right here in my room as well, because he gave it to me as a gift. That was another spectacular find in our own backcountry of the Central Coast. So many of you are quite familiar with Shell Creek because it's known for its spectacular spring wildflower displays during good years. We haven't had a lot of good years recently with drought conditions, but Shell Creek flows through this area. Off of Shell Creek Road, you can take this paved road, park your car, and come up to the road cuts here and search for fossils that have eroded out of the bank here. Well, I'm going to take you all virtually across the stream bed here to this slope or the flank of this slope to show you some rock outcrops. But I'm going to ask you all to be on your word now. If you ever repeat this trip yourself, don't collect fossils from this area because this is private land. It's all ranch land, and they're quite courteous to let visitors roam their private property, but they don't want you collecting fossils from right below the house. It's on top of that bluff. So please look, study, but don't take. However, along the road cut itself, this is, I believe, County Road. If fossils are eroding out, rolling down to the edge of the road, well, that is where I allowed some of my class participants to take home some souvenirs or fossil specimens. And the Santa Margarita Formation out here along Shell Creek is renowned again for its marine seashell fossils. Pectins were very large clams. One thought being that they had very robust, strong shells similar to pismo clams today. Perhaps these shelled marine invertebrates were surviving in shallow, rough marine conditions where there might have been, for example, turbulent wave activity. A modern analogy would be today's Pismo Beach. So the present is sometimes said to be the key to the past in helping to interpret what these fossils represent. So there's that drawing again, today's modern shoreline, in George Mason's drawing where he used this to represent the ancient shoreline at the time these specimens were surviving in a shallow inland sea. And this line, by the way, that cuts across and everything just seems to disappear along this fracture zone, that's the famous San Andreas Fault. So whatever used to exist on the other side here has been translocated or moved perhaps hundreds of miles from its original location because of the plate tectonic motion along the fault line. So that's another reason to go out and visit the Shell Creek area. There are spectacular fossil finds out there. Further inland on Highway 58, just before reaching the Carrizo Plain, we all cross over a bridge over the San Juan Creek drainage. And again, I encourage you to stop, but don't go out here onto private property without permission. This is again private ranch land, but you drive by and you can see this rock formation. You could even get out with if you have binoculars and see the fossils embedded right there on that bluff. And this again is the Santa Margarita Formation with the renowned pecten and even oyster fossils along this stretch of Highway 58. This is the beautiful San Juan Creek drainage. Okay, so if you'd like to get any more further information locally about our geology and some of our field trip routes, I encourage you to log into the California Native Plant Society website for the SLO chapter, and Dr. David Chipping, retired geologist, one of my inspirations for giving this talk today, has published a road guide to many geology field trips throughout the county, including the Highway 58 stops, many of the same stops that I mentioned in my virtual talk today. So with that, thank you all for your patience and hanging in there. And I hope you enjoyed our wanderings today through geologic time.